Gasoline. It is the most widely used fuel in the world and has shaped modern civilization more than almost any other substance. Refined from crude oil, gasoline is a liquid fuel produced through a process called fractional distillation, where crude oil is heated and separated into different components based on their boiling points. Gasoline sits in the lighter range of those components, which makes it highly flammable and energy-dense. It powers the vast majority of passenger cars on the planet and has done so for over a century. The internal combustion engine and gasoline essentially grew up together, each one evolving to suit the other. Different grades exist, measured by octane rating, which determines how well the fuel resists premature ignition inside the engine. Higher octane fuels handle higher compression without knocking, which is why performance engines often require premium grades. Despite the rise of alternatives, gasoline remains the dominant transportation fuel by a significant margin. Diesel. It comes from the same crude oil as gasoline, but behaves very differently. Diesel is heavier, less refined, and ignites not through a spark, but through compression alone. When air inside a diesel engine is compressed to a high enough degree, it heats up enough to ignite the fuel on contact. This makes diesel engines more thermally efficient than gasoline engines, meaning they extract more energy from each unit of fuel. That efficiency is why diesel became the standard for trucks, buses, trains, and ships, where fuel economy over long distances matters enormously. Rudolf Diesel, the German engineer who developed the engine in the 1890s, originally envisioned it running on vegetable oil. The fuel we now call diesel came later, refined to suit the engine's characteristics. It produces more torque at lower speeds than gasoline, which is another reason heavy vehicles favor it. In many parts of Europe, diesel passenger cars became extremely common before emissions concerns began shifting the market away from them. Jet fuel. Commercial aviation runs almost entirely on a fuel called Jet A, a type of kerosene refined from crude oil. It sits between gasoline and diesel in terms of its weight and composition, but it has specific properties that make it suitable for the extreme demands of aircraft turbine engines. It has a very low freezing point, which matters when aircraft cruise at altitudes where outside temperatures can drop to -50 degrees Celsius or colder. It is also stable under pressure and resistant to vaporizing at altitude, where atmospheric pressure drops significantly. Military aircraft sometimes use a slightly different variant called JP-8, which has additional additives for safety and performance. The energy density of jet fuel is one of its most important qualities, since every kilogram carried on an aircraft comes at a cost to range and payload. The entire global aviation network, moving millions of passengers every day, depends on a continuous and precisely refined supply of this single fuel type. Aviation gasoline. Not all aircraft run on jet fuel. Smaller, propeller-driven aircraft typically run on aviation gasoline, commonly known as avgas. It is a high-octane fuel specifically formulated for piston aircraft engines, which operate differently from the turbine engines found in commercial jets. One of the most widely used variants is avgas 100LL, where LL stands for low lead. It still contains small amounts of tetraethyl lead, an additive that prevents engine knock in high-compression piston engines. Lead was phased out of automotive gasoline decades ago due to environmental and health concerns, but the aviation industry held on to it longer because finding a suitable replacement that works safely across the wide range of piston aircraft engines proved technically challenging. That challenge is still being worked on, and unleaded alternatives are gradually moving toward wider adoption across the general aviation sector. Liquefied petroleum gas. Sold under names like LPG, propane, or butane depending on the specific composition, this fuel exists as a gas at normal atmospheric pressure, but is stored and transported as a liquid under moderate pressure. That property makes it practical to bottle and distribute without the need for pipelines. Propane is widely used for heating homes, cooking on grills, and powering forklifts and other industrial equipment. Butane is commonly found in portable camping stoves and lighters. In some countries, LPG is also used as a vehicle fuel, sometimes called autogas, and it burns more cleanly than gasoline, producing lower levels of certain pollutants. It is produced in large quantities as a side effect of other energy operations. Its versatility across cooking, heating, and transportation makes it one of the more quietly useful fuels in everyday life. Natural gas. It is found underground in vast reservoirs, often alongside crude oil deposits, and has become one of the primary energy sources for electricity generation, home heating, and industrial processes worldwide. Natural gas is composed mostly of methane, the simplest hydrocarbon molecule, which burns more cleanly than coal or oil and produces less carbon dioxide per unit of energy released. It is transported through extensive pipeline networks that span continents, and in places where pipelines are not practical, it can be cooled to extremely low temperatures to become liquefied natural gas, which can then be loaded onto specialized ships and transported across oceans. Compressed natural gas, known as CNG, is used as a vehicle fuel in many countries, particularly for buses and fleet vehicles, where refueling at a central depot makes the infrastructure practical. Natural gas became the world's fastest-growing fossil fuel over recent decades, largely because of its lower emissions profile compared to coal. Hydrogen. It is the most abundant element in the universe and produces nothing but water vapor when burned, which makes it one of the most discussed potential fuels for a cleaner energy future. Hydrogen itself does not occur freely on Earth in usable quantities and must be produced most commonly by splitting it from natural gas through a process called steam methane reforming, or by using electricity to split water molecules through electrolysis. When the electricity used for electrolysis comes from renewable sources, the resulting hydrogen is called green hydrogen and carries essentially no carbon emissions across its production chain. Fuel cell vehicles use hydrogen to generate electricity on board, with the only exhaust being water. Several car manufacturers have developed hydrogen fuel cell cars, and the technology is also being explored for heavy trucks, trains, and ships where battery weight becomes a limiting factor. The central challenge remains producing, storing, and distributing hydrogen at a cost and scale that makes it competitive with existing fuels. Ethanol. It is an alcohol fuel produced by fermenting sugars found in plants, most commonly corn in the United States and sugarcane in Brazil. Brazil built one of the world's most successful alternative fuel programs around ethanol, and a large proportion of the cars sold there can run on pure ethanol. In the United States, ethanol is blended into gasoline at concentrations typically around 10%, a blend known as E10, which reduces reliance on pure petroleum and lowers certain tailpipe emissions. It contains less energy per liter than gasoline, which means fuel economy decreases slightly when using higher ethanol blends. Flex fuel vehicles are designed to run on blends up to 85% ethanol, known as E85. The fuel burns more cleanly than pure gasoline in some respects, but the environmental benefit depends heavily on how the crops used to produce it are grown and whether land use changes offset the emission savings. Biodiesel. Where ethanol replaces gasoline, biodiesel offers an alternative to petroleum diesel and can often be used in existing diesel engines with little or no modification. It is produced from vegetable oils, animal fats, or recycled cooking oil through a chemical process called transesterification, which transforms those fats into a fuel that behaves similarly to conventional diesel. Restaurants and food processing operations generate large quantities of used cooking oil, and collecting that waste material to produce biodiesel is one of the more practical circular uses of an otherwise discarded resource. Pure biodiesel, known as B100, can gel in cold temperatures, which limits its use in colder climates unless blended with petroleum diesel. The most common blend is B20, which is 20% biodiesel mixed with 80% conventional diesel. It produces lower levels of particulate matter and carbon monoxide than petroleum diesel when burned, and because the carbon in the plants or oils used to make it was recently absorbed from the atmosphere, its net carbon contribution is lower than fossil fuels. Coal. It powered the Industrial Revolution and remains one of the most significant energy sources in human history. Coal is a solid fossil fuel formed over hundreds of millions of years from the compressed remains of ancient plant material. It comes in several grades, from lignite at the lower end to anthracite at the highest, with the grade reflecting carbon content and energy density. Bituminous coal sits in the middle and is the most widely mined variety. Burning coal generates heat used to produce steam, which drives turbines to generate electricity, and this process still accounts for a substantial share of global electricity production, particularly in China, India, and parts of Southeast Asia. Coking coal, a specific type processed into coke, is essential for steel production and is not easily replaced by alternatives in that industrial process. Coal's decline in Western countries over recent decades has been driven by cheaper natural gas, falling costs of renewables, and growing pressure to reduce carbon emissions. Wood and biomass. Long before fossil fuels existed, wood was the primary fuel source for human civilization, used for cooking, heating, and later for industrial processes like smelting metal and firing ceramics. It remains the main cooking and heating fuel for a significant portion of the global population. Burning wood releases carbon dioxide, but because trees absorb carbon as they grow, sustainably managed wood fuel can be considered roughly carbon neutral over time. Beyond simple firewood, biomass as a fuel category includes agricultural residues, dedicated energy crops, wood pellets, and organic waste. Wood pellets in particular have become an industrial fuel used in large power plants, particularly in Europe, where they are sometimes co-fired with coal or used as a direct replacement. The sustainability of large-scale biomass use remains a point of genuine debate among researchers and environmental groups. Nuclear fuel. It does not burn in any conventional sense, which sets it apart from every other fuel on this list. Nuclear fuel generates energy through fission, the process of splitting heavy atomic nuclei, most commonly uranium-235 or plutonium-239, releasing enormous amounts of heat in the process. That heat is used to produce steam, which drives turbines to generate electricity, similar in basic principle to a coal plant, but without combustion and without the associated emissions during operation. The fuel itself is processed into small ceramic pellets of uranium oxide, which are loaded into metal rods and assembled into fuel assemblies inside a reactor core. A single uranium fuel pellet, roughly the size of a fingertip, contains as much energy as around 800 liters of oil. Nuclear power plants can run continuously for extended periods on a single fuel load. The challenges surrounding nuclear fuel relate primarily to the handling and long-term storage of radioactive waste, which remains active for thousands of years.